Hello, my name is Mihir, and today I'll be presenting the demo for LogLens Team 19. And in this demonstration, I'll cover a quick recap, a demo, and how we also incorporated software quality metrics in our system. So just to give a quick recap, LogLens is an AI-powered log analysis and root cause diagnosis platform, which based on your which has context for the logs and your code, and based on the errors that you get in a production system, it will try to find the root cause for the issue and also generate and suggest some fixes for it. Uh, Moving on, for this presentation, we'll be focusing first on our MVP that we created till now. For this MVP, we mainly focus on errors that are caused during a CI/CD pipeline, like a GitHub Actions pipeline or a Jenkins pipeline, and ETL pipelines, which work on massive data sets and try to ingest data to different tables or process data and create some analysis. Uh, this demo will be from user's perspective. For now, our target user is a developer who will be using this in his day-to-day life, and we'll be simulating some realistic errors and exceptions that we generally get in the production systems. Our current MVP is a GitHub Actions plugin, which anyone can incorporate into their GitHub Actions workflow. And this will eventually be also a fully functioning platform covering other production system other than CI/CD and ETL pipelines. So let's move on to the high-level design. So currently, this is our high-level architecture. So let's say me as a developer will develop a new feature in my project, and once I have tested it locally, I'll push it to my branch on GitHub. This push generally in the production system have a GitHub Actions setup, which trigger a build for my specific feature, and this build then decides either it may be deployed to production or it may be deployed to Artifactory. In our case, within this GitHub action itself, there will be another plugin or another step that a developer will need to add, which will be a AI analysis, which will import our LogLens plugin. And based on the output of the workflow, it will be decided if the workflow was successful. The workflow just ends there and it deploys the build to the Artifactory. If the workflow is not successful, all the logs go through our LogLens plugin, and based on the analysis, LogLens will create a new GitHub issue uh, with the detailed analysis and solutions on how to fix it. And this issue will be again created in the same project, on the same GitHub project, and the user or the developer will be able to see it. Now moving on to the demo. We here in this demo, we mainly focus on uh, 5 different errors that we may get. We are currently our AI supports multiple possible errors, but for this demo, we wanted it to keep it short and show some realistic errors that a developer may get on a day-to-day basis. So let's move to the first error, which is out of memory error. This error is generally caused when program tries to load variables or data, which requires much more RAM than the system has. And to simulate this, what we have done is we have created a Python file which basically creates a very big array. So this is the Python file which will give us, so let's say as a developer, this is my project and I'm working on some Python file. In this Python file, I decide to initialize a dataset in which I create a NumPy array with 10 billion rows and 1 billion columns, 1000 columns. Now this will definitely creating this array won't have enough space in RAM because it will cross the 8 GB RAM, which is allocated to the GitHub Action workflow pipeline currently, and this will raise a real memory error. And let's see if our AI is able to catch it. So for this, what I'll do is I'll make a small change to README just to show how it should work. So as a developer, let's say I do a change and I say this is a new feature. I save this. I say I make a new commit, I added a comment, I commit this, Now, before syncing this, I'd like to show you what the hosted project currently looks like. So this project has zero issues as of now, no issues created, and has multiple scripts which I as a developer will be working on. And once I push this, it will trigger some pipelines. So for demonstration, I've created five different pipelines, which each of them run each of the different simulations of error, and those error each of the workflows, ultimately each of them will call our same plugin. So the plugin code is not different, but I separated this workflow just to give a clear idea and keep real examples and keep them separate from each other. So let's just post this code. Okay, this is done. So this should add another commit uh, to my repository. Yeah, it says added commit 1 minute ago. Now, if I go to actions, this will have triggered five different pipelines. Let's open all of them. Okay, so this one simulates out of memory error. So what this pipeline does is it will just run this my Python file that I showed currently, which tries to create a numpy array which crosses the memory limit. Yeah, so whenever I try to create this will throw this error, which is array memory error, unable to allocate 72 TB, blah blah blah. And this error will then go to our plugin, AI error analysis plugin. It will read all the logs, read the relevant code files, and based on that, it will create this new issue. And if we go to this issue, we'll see the details of what the issue is. So it says critical pipeline out of memory failure attempted 72 TB memory allocation. And it will give you a summary like 80 TB was tried, the memory requested was 80 TB, which exceeds the memory capacity of GitHub Actions Runner. Uh, it will give you like impact. Like this is critical because you cannot load this big of data on GitHub Actions, and all your pipelines will fail currently if you try to load this type of data. And it will also give you some recommended fixes. So here if you see it gives you one fix, which is what you can process all the data in batches, or you can use chunking to avoid loading all the data at once. And it also gives you some general suggestions of how to profile, how to debug, and how to go about this, and how to create scalable architectures that incorporate this. And finally, it will summarize everything and give you this generated list of what it thought it was issues. Next, let's move on to the other pipeline. Now, this is the dependency conflict pipeline. Um, what this does is now this is another realistic error that we may get on a day-to-day basis, which is a user is trying to install some pandas version and some numpy version, but these two versions are incompatible with each other, and user may not see any error on his local because he may have already installed multiple pandas version locally, and Python on local will select the correct pandas version that works with numpy. But this should also work with the hosted environment, and if the hosted environment tries to install this pandas with this numpy, this will give a real like an import error because the C extension that were used to build NumPy less than 2.0 is different and incompatible with C version that was used for Pandas 2.1 and above. And so this is basically how we simulate the dependency conflict. And this was the workflow that ran this dependency conflict. And if you see, uh, when it tries to import pandas, it will give you error. This is again a real error, which is expected 96 from C header, got this. Now this error is a bit hard to understand, but let's see if our AI was able to figure it out. It created a new issue for us. Yeah, so it says CI/CD pipeline failed due to dependency validation step because major one version conflict between NumPy and Pandas. So it was able to figure out which two libraries exactly gave the issue, and then it in the recommended fixes it gave us like what versions we should use for the library, and maybe we should consider upgrading NumPy, etc. And yeah, right now by default we are using Gemini 3, which is a small model, but it we found that it was enough for us to find out such issues. We also have an option to use Claude, which will introduce eventually once we have like a fully functioning platform to present. But right now, by default, we just use Gemini. Now, moving on next type of error uh, is a data type error. Uh, okay, we'll go one down. So this is a missing environment error. Let's say a user uh, locally in his local setup has saved some environment variable, for example, this model serving point, and in the code the user tries to read this variable which does not exist on production but it exists on his local. This will give a key error. Basically, a user does not has not created the API key secrets or some endpoint global variable, and this is the issue description created by Gemini for it. And it says basically failed during environment validation, attempted to access mandatory environment variable, this which was not defined in runner environment, which is the production one. And it also gave us recommended fixes, how to add this environment variable and how to correctly validate it, like use try catch, proper try catches, throw errors if I'm missing variables. Yeah. Next error is a flaky test error. So it happens once in a while if we use threads in our code. If we use multiple threads, the order of execution of thread may be different based on what each of the thread is doing. So here in this code, what we do is we create multiple threads that run this function, which is process. And for each thread, we have a different delay, different time of delay. So basically, first thread will be delayed sleep for this time, second will be slept for this time, and the ending of each of the thread will be different. And when we do t.join till all the threads finish completion, the order of completion will be different. So whenever a thread completes executing, we just add it to this common list. And in the end, we check the order that we ran the threads in and order that the threads were actually completed. If the order is different, uh, it may cause some issue in some production applications. So we generally put a assert for that. And to check that, this workflow basically gave one of this assertion error, which basically says the order, which was this, did not match the order of completion. And our Gemini has some analysis for it too. So it says CI/CD pipeline failed during integration test because model prediction does not guarantee or result ordering during asynchronous batch processing. And it also gave a way to like, fix this, which is map that preserves the order of the results. Now, last type of error is a data type error, which basically means whenever we are working in a big team, we generally have a microservice architecture, and uh, when as a developer, I will focus on the feature that I'm working on, and I expect a data to come to me in certain format. Uh, if those KPIs aren't met, it will throw error in my code, but it would be because of the malform data that I received from either from front end or other services. And these type of errors should be caught and quickly fixed. So this is another type of error, which is data type error. Now, the fix for this could be changing my code itself, which is basically being able to handle different types of data in my code, or having a strict policies against data type and not uh, adding that logic in the current service, but instead changing the logic uh, in the service that we are receiving the data from. So this is one of those example. Now this is a sensor data, the simulated sensor data, where readings are should be normally in float. These are readings for temperature, but if we get some string values, uh, it should throw error in our code because we are trying to compute min, max, and sum and length of all these readings. And when I try to do sum or min, it will give me an error because few of the elements in this list are string. And this is what the error looks like: unsupported operand, float, and string. It basically says you cannot do sum of float and string. And for this is what Gemini had to say. The CI/CD pipeline failed during sensor validation due to unhandled type error, and it gave fixes for it, which is filter out only numeric values and to avoid divide by zero errors, etc. So these are the few. And if you go to the issues, if I refresh this, These are like the five issues that Gemini created for us. Now, in the future, there is also an option to directly assign this to Copilot and give it some more description. But we're planning to eventually incorporate that in our platform itself, so users can keep editing and steering the direction in which AI is trying to fix your issue. So this was a live demo. Uh, Ultimately, currently, what our MVP does is based on the issue in the CI/CD pipeline, it will identify the issue and it will create the deep analysis for that issue, and it will create a GitHub issue for that project and recommend some fixes and how to prevent this such thing in future. And you can also assign it to Copilot to actually create a new PR to fix these issues. So this was our demo, and moving on to how we ensured we incorporated software quality metrics is first we our code is very modular, first of all, because it's now let me go to the implementation. So let's say this is one of the GitHub pipelines that a user or a developer works on, and to import our AI analysis step, all the user has to do is this, which is import our GitHub action plugin in his pipeline, and this will automatically and also pass AI API keys and AI model that he wants. Now, by default, we are using Gemini, but if you pass any other model, it will start using that model like Claude. And you can pass a GitHub token, but if you don't pass anything, it just uses this GitHub bot ID, so this GitHub Actions bot, and it will create that issue from that bot account. So yeah, since this is just a GitHub plugin, it's very modular. It can be used in any GitHub Actions pipeline, and the code for this is also as we see in the high-level architecture, it is very uh, um, modular because LogLens is only focused on getting the code, getting the error, and then performing the analysis. The infrastructure part is taken care of some other team. The code part, the feature part, the actual developer works on the features. This way, it's easy to integrate everything and everyone works separately. Next is scalability. So since this analyzer is just a GitHub plugin, it can be reused for different pipelines, and no matter what the error is, since we haven't trained it for some specific types of error, it can identify multiple different errors that could be possible. And it also leverages our existing project infrastructure from the developers, because the developers have can assign how uh, big of a VM they want to give to this GitHub Actions, and it will just run in that VM itself. It will not create a separate VM or run the code in a different VM. And it also uses existing GitHub plugin design, which basically just makes it easy to import it as a single step from any GitHub Action pipeline. And lastly, it's the security. We just use existing GitHub security features, and for any LLM, users are able to use any LLM provider. They just have to pass the model name and their API keys, and they can select any LLM that suits their enterprise data security needs. Moving on to improvements from Demo 1. So for Demo 1, what we presented was first of all a Figma prototype, which will show a log lens dashboard, which has all the details of all the failures till now. Secondly, we also worked on a front end, which looks like this, which would be our final loglens dashboard, where user can go to each of the failures and also get the details of fixes and the logs involved in the analysis, and also chat more and steer the direction of the fixes for our AI bot. Uh, we are eventually planning to create a database to integrate all this together, our GitHub plugin with our LogLens frontend, and that will be part of our next submission. So yeah, that was all for the demo. We hope you enjoyed the presentation, and we're looking forward for the feedback.